Welcome to the Deep Dive. This is where we take some pretty complex source material and really just break it down for you.
And today that material is from Stanford's CME295 lecture series on LLMs, specifically on evaluation.
Right. And today's deep dive is all about a really crucial question. How do you actually grade a smart machine?
It's maybe the most important question. If you're building or fine-tuning these models, you have to know how to measure them.
Now, we're not talking about system metrics like speed or cost.
No, not at all. Our mission today is all about the output quality.
So things like coherence, factuality, style.
Exactly. For all that free-form text or code or math that these models produce.
And to really get what we're evaluating, it helps to remember what these models are doing. They're using things like RAG, retrieval augmented generation.
Right, to pull in outside knowledge, and tool calling to interact with other systems.
Which all feeds into these agentic workflows.
Yep. The model isn't just writing text anymore. It's reasoning and acting. It's following frameworks like React Reason plus Act.
So it's observing, planning, acting.
A whole complex chain. And when it spits out that final answer, we have to know, without a doubt, if it was any good. That's the challenge.
Okay, so let's start at square one. The most straightforward method. The human standard.
Right. You just ask people to rate the output.
It sounds simple.
I mean, the ideal scenario is simplicity itself. You give the LLM output to a human, you ask them to score it, that's your ground truth.
But there's always a but.
Of course. The limitation becomes obvious really fast, it's incredibly expensive, and it's slow.
You just can't scale that.
Not to thousands or millions of outputs. It's not financially sustainable.
And even if you could afford it, you run into the subjectivity problem. The source material had a great example for this about a birthday gift.
Oh, that one's perfect. So you ask the model for a gift idea, and it says, a teddy bear is almost always a sweet gift.
Okay, it seems helpful enough.
Well, Rater 1 might say, great, that's super useful, and give it a high score. But Rater 2 might say, that's useless. Which stuffed animal? What brand?
And give it a terrible score.
Exactly. Two perfectly rational people, two totally different scores.
So how do you make sure your human raters are at least consistent with each other?
You need a health metric, an inter-rater agreement metric. Now, the first instinct is just to calculate the raw agreement weight.
Just what percentage of the time do they give the same score?
Right, but that's a trap.
Why is that?
Because of random chance. I mean, if you have a simple good-bad choice, two people just guessing will agree about 50% of the time anyway.
Just by luck.
Just by luck. So that raw number tells you nothing. You need a metric that accounts for that random agreement.
And that's where something like Cohen's kappa comes in.
Precisely. Cohen's kappa for 2 raters, or Fleiss's kappa for more, they quantify how much better your agreement is than what you'd expect from pure chance.
So a good kappa score means your guidelines are clear and your human standard is solid.
It does. But since we already know humans are too slow and expensive for every single output, the field had to pivot.
To the next best thing, automated rule-based grading.
Exactly. The idea was, let's manage our resources. We'll pay humans once to create a small set of perfect, ideal reference answers.
And then use a formula to compare the LLM's output to that perfect reference.
Yep. And that's where we get these classic rule-based metrics.
Let's unpack those. I think the one most people have heard of is BLEU.
Oh, for sure. BLEU, or Bilingual Evaluation Understudy. It came out of machine translation, and it's all about precision.
So it's counting word matches.
Basically, yes.
Okay.
It's counting anagrams, sequences of 1, 2, 3, or 4 words that match between the model's output and the reference. And it has a little penalty to stop the model from just giving super short answers.
And then there's Meteor.
Meteor is a bit more sophisticated. It looks at recall, too, using an F-score. But its big thing is rewarding good word ordering. It looks for matching chunks of text.
And I've also heard of Rouge, usually for summarization.
Right, a very similar idea.
But all of these sound incredibly rigid. They're based on exact word matching.
And that is their ultimate Achilles heel. They just completely fail when there are stylistic variations.
So if the model says the same thing but with different words,
it gets a bad score. Imagine our teddy bear example. The model could say something is comforting in 5 equally good ways, but if those words don't exactly match the single reference text,
BLEU and Meteor would score 4 of them poorly.
Exactly. So the correlation with what a human actually thinks is good quality is, well, it's pretty low. And you still had to pay for the humans to write the reference text in the first place.
So that fixed, rigid reference was the real bottleneck.
It was. We needed a way to evaluate quality that understood meaning and nuance, not just word order.
So how did we finally break out of that?
Well, this brings us to the modern solution, which is actually, it's both elegant and very logical. We use an LLM to grade another LLM.
LLM-as-a-judge.
Okay, that's the one.
The premise just feels so smart. Use a powerful model, one that's already been trained on human preference, to be your quality control.
And the benefits are immediate. First, you get rid of the need for those expensive, human-written reference texts entirely.
Because the knowledge of what's good is already in the judge model.
Right. And second, and this is huge, the judge doesn't just give you a number. It gives you a score and a rationale.
The rationale, that gives you interpretability. You know why it failed, not just that it did.
Exactly.
So what are the best practices here? How do you make sure your LLM judge is reliable?
There's a really neat trick in the POP structure. You explicitly tell the judge to output the rationale first and then the score.
Why that order specifically?
It forces a kind of chain of thought. The model has to lay out its reasoning before it commits to a number. And that's been shown to dramatically improve the quality of the evaluation.
And I'm guessing you can't just have it spit out free-form text.
Oh, absolutely not. Not at scale. You have to use what's called structured output. You constrain the model to return a JSON object so your systems can reliably parse the score and the rationale every single time.
What about the scoring scale? Is
Yeah?
it better to have, like, a 1 to 10 scale for more nuance?
You'd think so, but surprisingly, no. A binary scale pass-fail, good-bad, is often better.
Really? Why?
It's just an easier job for the LLM. You're not asking it to make a fuzzy distinction between a 7 and an 8. You're forcing a clearer, less noisy choice.
Okay, but even with all these tricks, we're still just using a proxy, right?
Yeah.
How do we know the LLM judge is actually measuring what we care about?
That is the critical question, and the answer is calibration. You still need to collect a small number of human ratings from time to time and run a correlation analysis.
To make sure the judge's score still lines up with the human ground truth.
Precisely. And for reproducibility, you always run the judge with a very low temperature, like 0.1, to make its judgments more deterministic.
Now we get to the really thorny part. Bias. Even our smart judge models have failure modes,
They do, and you have to actively fight them. The first one is position bias.
where it just prefers the first answer it sees.
Yep. If you asked it to compare response A and response B, it might just have a slight preference for A just because it came first.
That seems like an easy fix to just swap them.
The fix is easy, but it's not cheap. The remedy is position swapping. You judge A vs B, then B vs A, and take the majority vote. But you've just doubled your evaluation costs.
Ouch. Okay, what's next? The second one feels very human. Verbosity bias.
It really is. The judge might just prefer a longer, more detailed answer because it looks more comprehensive.
Even if the short, concise answer is actually better.
Exactly. So you have to put explicit instructions in the prompt telling the judge not to prioritize length.
And the last one sounds like LLMs have a bit of an ego. Self-enhancement bias.
That's a great way to put it. A model tends to think its own answers are better. It just probabilistically prefers its own style of generation.
So the solution is, don't have a model grade its own homework.
That's the guideline. Use a different, usually larger and more capable model as the judge than the one you use for generation.
Okay, let's go deeper on some really tough evaluation areas,
Yeah.
starting with factuality. A simple pass-fail just feels too blunt for a whole paragraph.
It is. It's way too blunt. The approach here is more nuanced. You first have an LLM take the output text and break it down into a list of atomic facts.
So you dissect the paragraph into individual verifiable claims.
Exactly. Let's go back to that teddy bear origin story. Say the model outputs, teddy bears, first created in the 1920s, were named after President Theodore Roosevelt after he proudly wanted to shoot a captured bear.
Okay, I can already spot some problems there.
Right, you'd break that down. Fact 1, created in the 1920s. That's wrong. It was the 1900s. Fact 2, Roosevelt proudly wanted to shoot the bear. Also wrong, he famously refused.
So you check each of those tiny facts individually.
You do, using REG or web search, just a simple correct and correct check for each one. Then you aggregate those scores, maybe with some weights, to get a final, much more precise score, like 0.6 out of 1.0.
That makes sense. Now for the really complex stuff. Evaluating a full agentic workflow. This isn't just text, it's a whole loop of actions and tool calls. Where can that break?
The failure modes get pretty specific. We can start with tool prediction error, so this is when the model is just deciding what to do. The first one is just tool omission, a punt error. The model needed a tool and just didn't call it. That's often a recall failure.
And then there's the opposite, where it calls a tool that doesn't even exist.
Tool hallucination. Exactly. That usually happens with a weaker model, or if the tool's documentation was just poorly written.
And if it calls a real tool, but it's the wrong one.
That's the wrong tool error. This often happens when your tool APIs are ambiguous. Search flight and check status might look too similar to the model.
And finally, right tool, but bad input.
That's the wrong arguments error, calling find nearest coffee shop but passing default coordinates like 000 because it forgot to get the user's location first.
Okay, so that's predicting the tool. What about when the tool itself fails? The tool call execution stage.
Right, now the bug might be in your backend. You could get a wrong response error, where the tool just returns a generic error message. The best practice is to always return structured output, even for errors.
What if it just returns nothing at all?
That's a big problem. No response. You have to return something, even an empty JSON object, just so the agent knows the call went through. Otherwise, it might start to hallucinate.
And the final failure point is after all the tools have run successfully.
Right, the response synthesis failure. The tool might return a huge, unstructured block of text that overwhelms the model's context window. It just can't parse it all to give the user a clean, helpful, final answer.
That is a lot of complexity to track. To wrap this up, let's map out the big public benchmarks everyone uses to get a profile of these LLMs.
Right. These benchmarks let us compare models across 5 core areas.
Starting with the basics, what does the model actually know?
That's 1. Knowledge benchmarks. They measure factuality, and they reflect the quality of the pre-training data. The classic example is MMLU, Massive Multitask Language Understanding.
And that's the one with all the different subjects.
Exactly. 60 diverse, multiple-choice tasks. Law, medicine, history. It gives a really broad snapshot of general knowledge.
Okay, next up is how well the model can think.
2. Reasoning benchmarks. These are multi-step problems. You have things like AIM, which is complex high school math problems, or PIQA, which is physical common sense, like how to get something off a carpet.
And for anyone building tools, 3. Coding benchmarks must be critical.
They're a fantastic proxy for tool usability. The standard is SWE Bench. It uses real GitHub issues, and the evaluation is simple. Does the model's code patch pass the existing unit tests?
Then we have safety and alignment.
4. Safety benchmarks. These measure if a model avoids harmful or toxic output. HarmBench is a big one. It's evaluated by attack success rate, basically. Can a classifier trick the model into saying something it shouldn't?
And finally, putting it all together for agents.
Right. 5. Agent benchmarks. A good example is TallBench. It simulates a full user journey, like booking a flight. And it uses a really robust metric called passhat at K. It doesn't just check if one attempt worked.
It checks if all K attempts in the workflow succeeded.
Exactly. It's a measure of true reliability.
This is a huge landscape of proxy scores. But we have to mention the big caveat here.
You absolutely have to. It's Goodhart's law. When a measure becomes a target, it ceases to be a good measure.
Meaning, if you just optimize for the test, you might not be building a good product.
Precisely. These benchmarks are amazing profiles, but you cannot blindly trust a leaderboard. The score is not the same as what a user actually needs.
Wow. We have covered the entire evolution of this. We went from costly human raters
to those rigid formulas,
Right.
like BLEU, that couldn't handle stylistic changes.
right up to the modern approach of LLM-as-a-judge, with all the biases like position and verbosity that you need to watch out for.
And we've mapped the whole benchmark landscape that defines a model's profile.
So what does this all mean for you? I think it means you now have the framework to look past the marketing hype on a leaderboard.
You can understand the real complexity behind how researchers make sure these models are reliable, factual, and aligned with what we actually want them to do.
And that brings us to our final provocative thought for you to take away. The biggest challenge in this field isn't just making the models smarter.
It's a constant, ongoing process of making sure our evaluation proxies, the judges, the kappas, the benchmarks, remain truly aligned with human ground truth.
Because if you stop checking that alignment, your model could top the leaderboard, but be terrible for your actual business.
The real work isn't just about the score. It's always about the correlation.
That's it for this deep dive. We'll see you next time.